The choice of the routing metric becomes very important because we cannot always choose minimum hop routing protocol as the most appropriate routing metric protocol. Therefore, we must first identify what are our goals. The routing problem has to be formalized now. In this module, we'll just skim over how congestion is aggravated through minimum hop routing protocol. How can we look at the routing problem as a more elaborate and thorough problem as compared to the minimum hop routing protocol? The authors have dedicated a whole section on that. You are strongly recommended to give it your own reading time as well. As we agreed, shortest path routing is the most congested routing protocol because if one or more links in the network happens to be the shortest or the critical hop through which the network routes its traffic, the network becomes choked because this link, which forms the subpath on the shortest path, will be repeatedly used for all the senders and destinations. The bandwidth would remain underutilized, although the network still could route traffic through those links. If we could, for the sake of convenience, understand that a link exists here and a link also exists here and here and here. In such case, we can imagine that if X takes the shortest path from A and B to Y, W still can get its data delivered. The partition is not taking place, but it cannot take the path from W to A to B and to Z. Rather, it will have to take slightly suboptimal path from here. It means that either W takes the same path or W takes slightly longer path. And of course, the later would be one of the choices if we do not want to congest this link AB. Therefore, routing turns out to be more than minimum hop problem. It is how users want their network to perform, the inherent topological connectivity issues of a network itself, the kind of traffic load that dynamically occupies the buffers of intermediate routers, and the QoS guarantees that are required by certain applications, for instance, real-time or interactive applications. Some strategies exist which provide an alternative to the shortest path. For instance, the shortest widest path, in which the shortest path is determined, which is the shortest, and then it is tried to get the widest path that takes its route away from the center of the network. It could be widest shortest path as well. In this case, first the emphasis is laid on determining a path that is the farthest from the centralmost path in the network, and then on that widest path list, the shortest path is chosen. Then the least loaded routing determines the paths which have been least threaded. Maximally loaded routing tries to optimize and utilize each link as much as possible. And lastly, depending upon the user, the application, or the data profile, routing decisions are made. All these form alternatives to minimum hop routing protocols.